So welcome back to Genknown tutorial, and for today's video, we will going to talk about the reinforced concrete. So ang unang topic natin is under the singly reinforced beam, and we have a problem here. We are requiring to determine or design the dimensions and the steel required, and also we need to investigate yung mga dimensions and yung steel natin based on sa mga given na ito. So before we proceed, please don't forget to click the like button and also hit the notification bell for you to be notified in our latest and future uploads, and also don't forget to hit the subscribe button. So under the first given, we have the dead load. I-assume na natin na ang dead load natin here is kasama na yung self-weight ng beam natin. Okay, the second given, we have the live load. We have, and by the way, ang dead load natin, as you can see, we have 10 kN per meter. Sa live load naman, meron tayong 10 kN per meter, and for the F prime of C, we have 20 megapascal. Ang Fy naman natin is equal to 275 megapascal. Ang length natin or ang length ng beam natin is 7 meter, and we will using 0.03 for the strain, and i-assume natin na ang depth natin is twice ng base. So ang unang gagawin natin dito is to determine the maximum steel ratio. So it may vary kung ano yung pinakamalaking lalabas dito. If rho is equal to rho 0.005 is equal to 0.85 F prime of C beta over Fy multiplied by the strain over strain plus 0.005. Okay, and the second one we have 0.004. Same formula but magkaiba lang ito. 0.85 F prime of C beta over Fy multiplied by strain over strain plus 0.004. By the way, if hindi pa kayo familiar sa mga formulas na ginagamit dito, I recommend you to watch the videos na naka-indicate sa ating link or naka-indicate sa ating description box. So, let's find out kung ano yung pinakamalaki sa nila. We have 0.85 multiplied by F prime of C is 20 multiplied by beta. By the way, ang beta natin, if ang F prime of C natin is less than or equal to 28, ang beta natin is equal to 0.85. Okay, constant na yan. Since ang F prime of C natin is 20, so we will using the beta is equal to 0.85. Okay, 0.85 multiplied by 275 multiplied by strain is 0.003 over 0.003 plus 0.005. So ito ay equal to 0.0197. And dito naman is equal to 0.0225. So, based dito, makikita natin dito na ang rho maximum natin is equal to yan, 0.0225. Okay, based on the code, ang allowed lang na pwedeng gamitin for the steel ratio is 0.6 ng rho maximum. Okay, that's equal to 0.6 ng 0.0225 is equal to 0.0135. So, solve na rin natin yung area ng bakal natin. We have the AS is equal to rho BD. Okay, rho natin is eto, by 0.0135 multiplied by B over D. I multiply by B multiplied by D, but we don't have the base and the depth yet. So the first thing we should do is to solve for the resisting moment Rn. We have Rn is equal to the rho Fy multiplied by the quantity of 1 minus the rho Fy, okay, over 1.7 F prime of C. Okay, ang Fy natin is given, F prime of C natin is also given. So that's it. We have 0.0135 multiplied by 275 multiplied by the quantity of 1 minus 0.0135 times 275 over 1.7 of 20 megapascal. So ang Rn is equal to 3.307 MPa. Okay? So by the way, we need to solve the factored load. So factored load, ang allowed is 1.2 ng dead load plus 1.6 ng live load. Ang dead load natin is ito, ang live load natin is 10. So ang answer dyan is equal to 28 kN per meter. Okay, by the way, singly reinforced din tayo. So ang moment na gagamitin natin dyan is the factored load multiplied by length squared over 8. Okay, so we are already familiar with this moment formula, no? So 28 multiplied by 7 squared over 8. That will give us 28 multiplied by 49 over 8, 171.5. Okay, the unit is in kN meter. Okay? Since factored load to, so factored moment din to. So, recall natin, we have the formula mu is equal to phi, or the coefficient or reduction factor multiplied by the resisting moment, b squared. Okay, take note of this. Remember, ang relation ng b and d natin, ang d natin is twice ng b. So, we can say na ang b natin is d over 2. So, phi is equal to rn, that's wrong. Is equal to rn phi, okay, d over 2 multiplied by d squared, or the mu is just equal to phi rn d cubed over 2. So, solving for mu, we have already solved it. We have 171.5 times 10 raised to 6. Para maging Newton, mm siya. So, ang phi natin is equal to 0.9. Okay, 0.9 ang ginamit natin for phi. In-assume lang natin na nag-yield na yung bakal natin. So, ang Rn natin is equal to 3.307. Okay, times d cube over 2. Solving for d, okay, 171.5 times 10 raised to 6 is equal to 0.9 multiplied by 3.307 multiplied by d cube over 2. So, ang d natin is equal to 486.64 mm. So, round up natin yan. Let's say that is equal to 490 mm. Remember, ang d natin is kalahati ng b. So, ang base natin ngayon, so 490 divided by 2 will give us 245 mm. Okay, take note sa BND natin. B natin is equal to 245 mm, and ang d naman natin is equal to 490 mm. Okay, remember the formula kanina, we have the AS, or yung area ng bakal, is equal to rho BD. So, we can now solve the AS now. So, AS is simply rho 0.0135 multiplied by B is equal to 245 times D natin is 490. That will give us 1,620.675 mm squared. So, AS is equal to 1620.675 mm squared. Okay? So, ang next na solve natin, since we have the dimensions now, ay yung dummy at kung anong size ng bakal. So, i-try natin yung, let's try 20 mm na bakal. So, N20 is equal to AS, or 1620.675 over 5 over 4 multiplied by 20 squared. Okay? 1620.675 over 5 over 4 multiplied by 20 squared. That will give us 5.15. Let's say 6 na bakal. Okay? I think masyadong madami. So, let's check kung adequate ba yung spacing ng bakal natin. Ang B natin is 245. Is equal to 6 na 20. Okay? Plus 5 spacing. Okay? Plus, i-assume natin ang concrete cover natin is 40. Dalawang 40. And yung stirrups natin is dalawa din. Assume natin na 10 mm. So, ang spacing natin is equal to 245 is equal to 6 na 20 plus 5 S plus 2. Ayan. So, 5 lang. Which is clearly hindi pwede since ito ay less than sa 25 mm. Kailangan mas malaki yung spacing natin sa 25 mm. So, itry natin ang 32 mm. So, ayan. 1620.675 over pi over 4 multiplied by 32 squared. Yun, we have 2.01. Sabihin natin 3 peraso. So, let's check the spacing. We have 245 is equal to 32 plus 2 spacing plus 2 concrete cover and 2 spirax. So, ang spacing natin ngayon is equal to 24.5. So, hindi pa rin pwede. So, itry natin ang 36 mm. Nabakal? I think dalawa na lang to. 20.675 over 5 over 4 multiplied by 36 squared. That's equal to 1.59 clearly, dalawang bakal na lang. So, dalawa, 36, isang spacing, dalawang ganyan. So, ang spacing natin ngayon is equal to 245 minus dalawang 36 minus 100, that is equal to 73 mm, which is greater than 25 mm. So, okay siya, okay. Okay na gamitin ang 36 mm. So, overall, ang na-design natin is ang base natin is 245 by 490 and gagamit tayo ng dalawang 36 mm na bakal. So, remember also the moment kanina, we have 171.5 kN meter. So, kailangan natin yan to determine if safe ba na gamitin itong mga ito para sa ating beam. So, we have the compression is equal to tension tayo. 0.85 multiplied by F prime of C AB is equal to the tension is ASFY lang. So, 0.85 multiplied by 20 times A multiplied by B is equal to, again, 245 is equal to, ang AS pala natin is, eto, no? So, pi over 4 multiplied by 36 squared multiplied by 2. Fy is equal to 275. Solving for A. Ang A natin ngayon is equal to pi over 4 multiplied by 36 squared multiplied by 2 multiplied by 275 over 0.85 multiplied by 20 times 245. So, ang A natin is 134.4 watt 3. That's in mm. So, remember, meron tayong formula na A is equal to beta C. Remember, ang beta natin is equal to 0.85. Solving for C, C natin dyan is yung neutralizing. Is yung neutral natin. So, division lang naman yan. C natin is equal to 158.1334 mm. Ngayon, we will going to check if nag-yield ba talaga yung bakal natin. So, we have the formula Fs is equal to 600 multiplied by the quantity of D minus the C over C. That is equal to 600 multiplied by D, ang D natin is 490, minus the C is 158.1334 over 158.1334. equal to 1259.189, which megapascal, which clearly we can see na it is greater than the Fy 275, meaning tama lang yung ginamit natin ng neutralizing factor is equal to 0.9. Okay? So, ang next na gagawin natin dito is to check if greater ba yung mu na lalabas as compared dito sa mu natin kanina. So, we have the formula for mu is equal to phi as Fy multiplied by the quantity of d minus a over 2. Remember, ang a natin is equal to 134.413. So, mu natin ngayon is equal to mu is equal to 0.9. Okay, 0.9 times ang as natin is eto, pi over 4 multiplied by 36 squared multiplied by 2. Okay, 2 multiplied by Fy, we will still using this one, 275 multiplied by d is 490 minus a is 134.413 over 2. So now, ang mu natin is equal to, okay, 0.9 multiplied by pi over 4 multiplied by 2 multiplied by 36 squared multiplied by 275 multiplied by 490 minus 134.413 over 2. So, ganyan ang lalabas dyan. Gawin nating kn meter. Divide lang natin yan. 10 raised to 6. Yan. So, ang mu natin ngayon is 213 or 213.024 kn meter. Which is, we can clearly see na mas malaki itong mu nito as compared dito. Meaning, safe na gamitin itong mga dimensions na ito para sa ating beam. Safe. So, ito na yung end ng solution natin for problem number 1. And, see you in our next video tutorial. Goodbye.